Okay, welcome everybody. Hey Don, I'm glad you're here because you're going to be one of our experts today.
Okay, well, that's good to know. Thanks, Jay.
Yeah,
Good
well,
to see you too.
Yeah, what we wanted to talk about is essentially putting together what amounts to a standalone system, but also the low cost AC or DC coupled systems, how that would work, what are the issues, what to look for. So we had discussed it a little bit last time, and some folks wanted to get a little bit more into detail on it. Before we get started on the news, let me just update everybody. There are a couple of webinars coming up here soon. There's one on integrating renewables into the grid. So there's a NREL scientist who's going to be speaking. If you want the registration information, just put that in the chat. Make sure you give me your email address so I don't have to search around for it if you want these things. That's going to be tonight at 7 p.m. Eastern. Then there's a Generac micro inverter webinar tomorrow. So Generac's getting into the micro inverters. That'll be interesting. Be curious to see if it's just like an OEM kind of thing where they slap their label on somebody else's product, but we'll see. And that's 10 a.m. Pacific or 1 p.m. Eastern tomorrow. So I can send you that. Then there's also going to be a conference in Dayton, Pathways to Decarbonization, coming up September 14th. So if you're in, that's going to be at Sinclair College. So if people are interested in that, I can hook you up there. Okay, so let's get into the solar news this week. The solar jobs census report was just released, and its employment is up about 9% year over year. It's kind of a little bit misleading. When I look at these numbers and look at the graphs, it looks like there was a very, very rapid increase in employment up until about 2016, and then it's kind of leveled out. Right at about 250,000. Right now it's at about 255,000. But in 2011, it was at 105,000. The big states where a lot of this employment is taking place is California, of course, that's like 75,000 out of the 255. Florida, Massachusetts, New York, Texas, those are all up over 10,000. And then Arizona, Colorado, Nevada, and Ohio. So Ohio gets right up there in the top 7,000 to 9,000. So I was surprised. The only surprise there is Ohio, but we're the heart of it all. So what can I say? And of these people who are in there, 66% are installation and project development. That's who we would assume when we're thinking about solar. The guys installing, the guys designing. 13% in manufacturing, 11% wholesale and distribution, 5% operation and maintenance. That number kind of surprised me that there are that many in the care and feeding of existing systems. And then 5% is just other, who knows what that involves. People who teach solar, part of the overhead, that kind of stuff. Okay, so
did you have manufacturing in there?
Manufacturing was 13%. That was the second.
Is Ohio got that plant up in the Northwest yet? Is that what's maybe giving us some numbers?
It could be, because Ohio does have, what is that, First Solar? It's located up near.
I was thinking, yeah.
Yeah, like Perrysburg, I think. I think it's the largest solar manufacturing plant outside of Asia.
Yeah.
Okay.
Yeah, and they do a lot of commercial solar. We see that in the news all the time. I don't usually report on it because I don't care how many people bought First Solar panels or whatever. They're always reporting that kind of stuff. But a lot of commercial solar stuff. One thing that was interesting, and this may be one reason for the plateau, is we've seen much of the growth in solar has been in the utility scale and of course in the commercial scale, but mostly in the utility scale. And when we look at this, like in 2021, residential solar accounted for about 18% of all the installs in the US, but it accounted for 51% of the employment. So utility scale, lot of install, but not a lot of employment. Everything's highly mechanized. And it may also be because I know at least the utility scale projects I've seen here in Ohio, they basically contract with local labor unions and the like to just pull people in to install stuff, carry panels, slap them on. So maybe that doesn't qualify as full-time employment in solar, since many of these projects might be just temporary. Who knows? But anyway, I just find that as residential becomes a more important part, it's going to certainly be more important in employment. New Mexico's community solar program is in jeopardy. Apparently, they've had a couple of years of hearings, and they're going out with this community solar thing. And then at the last minute, Xcel Energy, which is the utility, filed an appeal with the state Supreme Court to try and block it. And they figure that's going to tie things up for a couple of years, keeping it all out of production. Now, community solar, of course, I know you guys mostly know, but that's where you can buy into a part of a larger system because your home is not appropriate for solar, whether you rent or it's shaded or whatever. They estimate about 75% of the people in New Mexico would not be able to install solar on their home for a number of reasons. A lot of that is because they're renters. A lot of it is they don't have financial credit to borrow money, so they could buy into a project, but they couldn't get a bank loan, for instance. So I've seen estimates as high as 80% nationwide would not necessarily qualify for solar on their home. Orientation of the building, shading, financial, they're renting. It's their mom's house and their mom hates solar or whatever, who knows. Speaking of their mom's house, I find this kind of interesting that the SunGauge Financial is raising the limit on loans for solar because solar projects apparently in residential environments are getting bigger and bigger. They've raised the cap to 200,000. And one of the things they cited was multi-generational homes. And apparently 60 million people in America live in multi-generational housing, which represents about 18% of the population. And I think, and this is a record number apparently. So the idea of the Waltons, it's not going back. I think a lot of it is high cost of childcare, high cost of housing. Younger people just simply cannot afford daycare. They cannot afford housing. And as I pointed out to my wife when I was reporting this, they also don't know how to do their own laundry. So they sure don't know how to go out and buy a house because we're raising a generation of babies, but whatever. So who knows, man-child. Okay, so that was interesting. And also Panama might become a center of solar manufacturing. You were mentioning there, Tony, that Ohio is the largest facility outside of Southeast Asia. Because of all the tariff issues, that we're talking about bringing it back to America, supply chain issues and the like. But apparently they like Panama a lot better because the median income is about 1/4 what it is here in the United States. And it is a tariff-free zone as far as the United States is concerned. And it is a direct shipping route to all of the major ports within the United States. Everything passes through the canal. So we may see this major shift of manufacturing of solar components ending up down in Panama rather than in Toledo. So we'll see.
Jay, I did see some people talking about that. I guess, is there a lot of stuff, not just with solar panels, but a lot of stuff that's electronic that needs people's actual hands? They can't, they don't have robots to do all of it yet. So they said because you have lower income wage scales in South America, Latin America, they were going to move a lot of stuff back from Asia to the US. And again, it avoids all the early issues with China. But that seems to be a big trend going on now.
Yeah, it makes sense. I mean, I don't know this for a fact, but it would not surprise me that it would be easier to get product from Panama to New York than from Omaha to New York. I mean, just because of the way these things work, especially when you're talking large volume, large bulk. So
Cheaper to ship on the water than it is by land by like 12 times or something.
yeah, yeah. And yeah, you just put those containers in there and then you just slap a container on a truck and you don't have to, I mean, driving across Pennsylvania, I would rather go by sea from Panama than try and drive across the Pennsylvania Turnpike. So now I've made fun of Pennsylvania, I've made fun of every 20-something-year-old, and let's see who else we can offend here today. So, all right, so.
Now, SunPower and Enphase both have been producing hardware in Mexico as well, or at least assembling it.
Yeah. Yeah, it's funny. I know when I got all of my Enphase microinverters, I thought it was so funny. It says proudly designed in California or in the USA. And then in very small letters, it says assembled in Mexico, you know? So I'm like, yeah, I thought about it when I was vacationing in San Francisco, but let's send it down to Guadalajara to put it together. So, all right. Okay, so we were going to talk about, I think, who was it? It was Eric, I think you had raised the issue of wanting to talk about some of these smaller systems, how we can take things, incorporate grid backup. As I recall, trying to remember who was, yeah, Eugene, I think you were talking about a system that you were working on. And so I thought we'd just kind of open this up rather than me try and lead the discussion on this, because many of you guys have done more on this than I have. I thought we'd just try and kick it around. I raised a couple of issues. When you start to try and do grid backup without an integrated pre-designed system, you know, what are going to be your issues? What are you going to run into? Because many of us like the idea of cobbling something together and saying, can I get around the fact that my microinverters are going to shut down when the grid goes down? Can't I go out and disconnect from the grid and somehow convince my solar array that it's still functioning, so it's producing? And can I have emergency backup without going out and spending $40,000 on some integrated system? The answer may be no, I can't do that. I don't know. So let's kick this around a little bit. Why don't we start out? I'll just ask Don. So Don, since you've got a system that is essentially a pre-engineered, is yours grid coupled or is it completely autonomous?
One is completely off the grid where I'm sitting now, and the other one is grid tied. The inverter's got the transfer switch inside of it, so once the grid goes down, I've had blackouts in the neighborhood before. I'll be sitting back in my kind of back of the house where I have it all lined up, and you know, I have no idea there's a blackout. All of a sudden, I look around outside. There's people outside with no lights. And my uncle comes over and asks, you know, why are your lights still on? Everybody else is out. So they
and
think
you're
a witch.
using the Solarc. Is that in both of them?
Yeah, I'm using Solarc in both of them. It's a fairly easy integrated system. Frankly, you don't have to do much except wire it up to the at the house. I wire it up to the grid and to the back, and I select which circuits to go ahead and flow through. But it was pretty straightforward. I know I didn't have to put like I said, I didn't have to put a separate transfer switch in, which you would normally need to do. It's got battery backup, so it'll, you know, it's got two lithium-ion battery backups there.
What size batteries is that? Is that the 8 kW?
I think the 7500s. Two of the 7500s I got from Alti.
Okay. And so you said that the auto disconnect, the transfer switch, is built into the inverter. Do you have a generator that's hooked into that as well, or not?
I do not at the house. Here at the farm, I do have a generator that is hooked up. But again, we're completely off grid here. So and I don't use lithium ion here. I use what is it? Kind of the gel lead acid battery ones, carbon something. But the system here, again, if once it gets down to the preset number, if it goes down to 50% or below, it triggers itself to start the generator.
And the generator is designed just to recharge the batteries, or is it designed to run your loads?
It could do both. I mean, once you've turned it on, the inverters think it's the grid. So it'll first charge the batteries to 100%, but if you have a load running, it'll run the load too.
Okay. And one of the issues that comes up when you have a solar array specifically is that with an AC coupled or a DC coupled system, usually with an AC coupled system, you've got a grid tied inverter, and then that grid tied inverter feeds a inverter charger, a battery based inverter charger that then is connected to your batteries. So it comes from your array and it goes through the grid tied inverter, and then it is at that point AC, and then the AC is fed into the AC end of the inverter charger, converted to DC, and charges the batteries.
The batteries, that's right.
Then, of course, when you're drawing from the batteries, the process is reversed and it goes through the battery and goes to the load. So one of the issues we run into is if your array is going at full production, normally those inverters are designed to produce at full production. The grid is there as a unlimited load dump. So, so when your grid is disconnected, and you fooled your inverters into thinking, or your inverter into thinking the grid's still going, that power's got to go somewhere. And so oftentimes they have what they call frequency dithering, I think, where it sort of messes with it to confuse it, to shut down basically, or to produce less.
Let me ask you there, Jay, when you say the power has to go someplace, like if I had a wind turbine, yes, the power always has to go someplace. You have to have a dump. But I thought for solar that if you didn't have anything that was a load on it, that it would not draw the power.
Yeah.
Am I thinking about that wrong?
No, you're thinking about that right. Except I think that it's because these inverters are set to produce. The solar panel will stop producing. But I think the inverter wants it to continue to produce at full max. So I think what's happened there is it's taking, once it's into the AC world and it is an AC output, it's got to go somewhere.
Yeah, once it's AC, once the inverter's pushing it out.
Right.
Yes, I agree with that,
So you've got to have some sort of charge controlling mechanism probably before your inverter if you're going to keep that from happening. You know,
well, is your inverter going to pull more than let's say you're convinced that the grid is still there.
Yeah.
And you're producing 100 from the panels, and let's say your batteries are full for argument's sake, and you only need 50. I guess, is the inverter going to go ahead and pull the full 100, or they're just going to take 50 because that's all you've got a load for?
Yeah, my understanding is the way the grid tied inverters are designed, they want to pull 100% of available power from the array, and it's going to assume there's either load or grid, which it will distribute that power to, unless the grid isn't operational, and then it'll shut down completely. So that's the basic design of a grid tied inverter. So now if we're on the opposite end, the AC output side of that inverter, and it's producing 100% of what's coming from the array, where is that power going to go? And obviously,
if you don't have a dump, you got a problem.
Yeah, you've got to have, or you could have some sort of charge controller mechanism that becomes the traffic cop, and that can happen within the inverter, or it could happen as a separate within the battery based inverter, or within a separate unit charge controller. And my understanding is they often use, as I said, frequency dithering to mess with it, which I guess by adjusting the frequency, the hertz, you end up reducing the output to control it. But I guess that's just a charge controlling mechanism there.
But
So-
again, unless you have some kind of battery, I remember a couple of weeks ago, you talked about one of the inverters that talked about it would do it in stages. If you
Yeah.
had up to so much, it would charge, 60. If you had 100, it would charge 100, but it would drop down a step to 60 or 50 or whatever it was. Unless you have a situation like that, you're going to have so much variability from this. Maybe if it's a sunny day, maybe not, but it seems like there would be a lot of variability in what's coming in.
Right. Well, that's another issue that we need to address, because let's
Mhm.
assume, well, I'll bring up my other issues and that I raised, or at least that occurred to me, and then we'll kick it around and let other. So let's say you want a battery. I'll get you in a minute, Bob. So you want a battery, but you don't want to put in a big battery bank. You just want a battery enough to fool the array. Well, how quickly is that array going to charge that battery? If you're overwhelming it with power, then you're going to damage the battery, because not only do they have discharge limitations, they have charging limitations. So that's an issue. Could be addressed with a charge controller, of course, but this is an issue. And then how do you deal with the variability of output versus load demand? And this comes into effect with the N-phase IQ8, where there is no battery, but they say, okay, we're going to put you into isolation or island mode, disconnect you from the grid with some sort of auto transformer, and then you're going to use just what's available on your array. But the output from that array is going to vary, but your loads may or may not match up with the available power. So they've done that through a set of priority circuits, and you have to predetermine that if I don't have enough power to run all three of them, I'm going to shut down this one, and then I'm going to shut down that one, and I'm going to shut down all of them, and then they're going to reconnect when the power is available. So you're going to have things turning on and off, and it's going to be a mess. So most people will probably opt to even that out somehow with batteries in some form or fashion. So sizing of that. The other thing is, if you're going to do it yourself, you want to make sure that you size the battery-based inverter. The recommendation is 125% the size of the solar array inverter or the grid-tied inverter, because the power from that grid-tied inverter is going to go through your battery-based inverter and go to your batteries. So you don't want to fry out all the components of your battery-based inverter by overwhelming it with the capacity output of the array inverter. So they recommend putting it at 125%, because, the variability of the sun, you may actually get better output or whatever. So anyway, that's the recommendation. And, everybody always says 125% is enough to solve the issue. So, all right. Yeah, Devin, you had a comment? Looks like you're on an airplane or something. So.
No, I have a question to ask, right? You have a grid-tied system on a commercial installation. The commercial installation has a generator on site for backup. How do you work that grid-tied inverter feeding into that system when you know the generator will come on when the utility fails?
I'm not sure I got your question. When will the generator kick
All right.
on?
No, okay, so let's assume utility power fails. The backup generator comes in, kicks in. But your grid-tied inverter is connected to the load distribution at the same time. So it's going to be same power from the generator feeding into the load. So I assume here that the grid-tied system inverter will continue to provide power to the loads. Is there going to be any negative sizing consideration in terms of how much power comes from the inverter versus what the generator is? In other words, is there going to be any possible negative impact on the generator itself by having that grid-tied inverter?
Okay. I think, all right, if I understand what you're asking, if you've got an inverter that's powering some load and a generator that's powering some load, what is the negative impact on either the inverter or the generator, and how does it know how much to send from which? Is that where you're getting to? Sort of. Well, one of the issues, and maybe this addresses what you're asking, is, and I'll try and remember this because I did write a section in the most recent textbook. Typically, when you have a generator that's backing up your loads, normally you're going to run your loads from the generator because there's concern that if you're feeding into your inverter, you could somehow damage your inverter and the electronics by feeding it in and overwhelming it. Or it could be that the signal from that inverter surges and is not clean, which could cause some damage. Now, I know when I looked at the Solarc, they have a controlling mechanism within that that's supposed to prevent that from happening. There is a physical connection point within that inverter for a generator that's designed for that very purpose. But if you're just adding a generator into a system and you don't have that inverter that's designed to receive it directly, then they typically want to isolate the PV system from the generator and run all of the loads from the generator, which doesn't really help out. It's the same issue of islanding, you know, that you're not getting the advantage of your solar array when you're in that kind of mode. So I think
Also, you're running your generator the whole time. I mean, the idea is if you run your generator, power up your batteries, turn the generator off, you know, otherwise your generator is going to run 24 hours a day if you're off. If you have it charging batteries, it's maybe 6 hours a day, just as far as how long it's going to your fuel last. But
Well, there's no
Jay,
batteries. There's no batteries in this, huh? Pure grid tie connection. I just want to know because I did have a query from a potential client. And this is a commercial scale system. It's not residential. It's over 100 kilowatts in size. They have a three-phase generator that is connected right now to the building property. But integrating a grid tie system with that, I just wanted to find out what were the challenges and issues if they already have a grid tie that is going to kick in when utility fails, and the inverter might kick in by itself because it's in power.
You said this system doesn't have batteries?
No, it's not batteries. Pure
Okay.
grid tie.
Yeah, I would say that unless your inverter is specifically designed to receive a generator, then you're going to want to take that attitude of either you're running from your solar or you're running from your generator, but you're not trying to do both. So I think otherwise you're going to run into some electronics issues. Maybe fry out your whole generator or your inverter system, or you may, you know, backfeed into your generator too, I guess. That's a possibility.
All right.
So
Okay.
in the book that I sent you a copy of, there is a whole section on that. Look at the integrating generators into commercial systems, and it will explain it better than I remember it, because that was all new to me when I wrote it. And I promptly forget this stuff, just like all the students forget it when I teach them, you know, it's like, so it's all designed just to get through the test, then it's gone, you know, so. All right, Bob, you had raised your hand a second ago.
Yeah, going back to the conversations of off-grid and determining how to use a grid-tied micro inverter, which has this tendency to be on. In the binary world of electronics, controllers are usually set to be on or off. If you want to control it more, it's on more. If you want it, it's less. So if you shut off the power going to the inverter or the load, then it's going to shut off at that point. It won't even know what kind of AC sign to put out or anything else. So if you go and default to the batteries, as long as the load is within a certain area, and then when it drops down and requires a higher output, then it's a simple thing just to turn back the inverters on again. So from a binary on-off type of situation is a simple solution to the problem.
Don, you had mentioned, I think once before when we were talking on this, that you do see your generator sagging sometime or when, how, just what's your experience? What are the issues? Have you run into any issues with the generator?
With running it straight into the inverter, I will see it where it's a 20K generator, so it can pretty much handle whatever the house would have, obviously, but it would have charging the batteries too. It can when the solar is also on, so if the sun's out at the same time, if for whatever reason, if there's a situation where it was sunny, but for some reason the generator kicked on, until recently I couldn't turn it off. So if it kicked on like at 5 o'clock in the morning, I didn't have a way to turn it back off initially. And it, if all of a sudden it didn't need the power, the generator would dial down, to a lower speed, would produce less power, and then would jump back up when the sun went back out or when it needed. If there was a heavy draw, if the heat came on, that was another thing that happened in the summer. In the wintertime, auxiliary heat would come on because it's a geothermal system, and that's a heavy electric load because it's just a induction heating across the wire, then blowing it out. That would also create a fluctuation, which sometimes, if it was bad enough, could knock the system out of the, I guess what was happening was it was knocking it out of whatever the expected range was for the input, the hertz or whatever, or the voltage, and it would kick the generator or the inverters back off. Is that what you were asking? I was
just
I was
seeing
following
what-
Bob, but I wasn't completely following. Yeah.
Just seeing if there's experiences or issues that we're running into. I think when we sort of prompted this, I know Eugene, you're working on a project where it's much smaller scale, because I'll tell you what sort of got me thinking here on how to address this was we were talking about cobbling something together. Can we MacGyver something that's kind of fun and not going to be super expensive? When I started looking at the prices of commercially available systems that are out there, it gets pricey pretty quick to just have any sort of AC coupled system. You're talking about like the Solarc inverter charger is what, $6,100 just for the unit. You don't have to have an auto transformer, but so that would be like an 8 kW inverter charger. Then when you start throwing in batteries, so if you don't mind, Don, what would be roughly system cost on something like that for an AC coupled or even the standalone?
How many batteries are we talking?
I don't know, enough to,
Well, let me put it this way. What's the average house uses 30 kilowatt hours a day?
yeah, pretty much.
I think I use more than 120.
Yeah, okay,
So
so you're
I don't know that it would be a representative system.
right.
I'd say the batteries were about, again, I was using the Solarc batteries. They were about 600 a piece, maybe. And so 4 for a bank, 12 volts each.
How many-
It would depend. I mean, I think what you said for the pricing was about right. It might be 6,100 now. It was about 5,000 when I bought them. Prices have been going up. Although I think that's a 12K system now, isn't it?
8K is what that price was.
Well, they haven't sold the 8K in a while, I didn't think.
Yeah, well, I was just pulling the cheapest price, but I saw some of
Okay.
these systems when they were giving me system prices, it was 25, 30,000 bucks just for.
Oh, easy. Yeah.
Yeah, for those. And I know Eugene, okay, yeah, since you prompted all this discussion, let's have you say
Well,
something.
I do have a large system, a full house battery backup that's wired to my auxiliary load panel of critical loads, but that's many loads actually.
Mhm.
So I have, similar to Don, I have a lead acid and gel cell battery backup of about 20 kilowatt hours. Of course, you don't want to draw it down fully, you know, more than once or twice. And I use a Schneider Electric Connext series battery inverter, 24-volt battery bank, 3 kilowatt inverter, 240 volts, of course. So that's wired in. That's wired into my auxiliary panel, and I uploaded the latest firmware to the Connext, and it was supposed to do the frequency dithering that you spoke about. So I checked that. And it does properly. Hold on a second. It does properly increase the frequency to about 61.5 hertz. And sure enough, I see the microinverters cutting out when they see that higher frequency. So the issue with my system is that my solar string that's fed into that auxiliary panel is 6 kilowatts, and the inverter is only 3 kilowatts. I think I want to get 120% inverter capacity, you know, power rating. Anyway, so I don't run it under full sun, you know. I run it manually and switch it in and out. If the power goes out and the full sun is out, I have the ability to switch individual solar panels in and out, the DC from my basement, because my microinverters are in the basement in a big bank. So I have toggle switches on them. I can switch them out individually.
Boy, that is MacGyvered.
It is.
No risk of human error there, you know.
Right. I have meters on it, so I know how much wattage the array is putting out immediately. But one issue I have, and I'm not quite sure what's causing it, when the grid goes down and this thing automatically switches to the battery-based inverter, and then the micros come back online after 5 minutes because they see a good sine wave from the battery-based inverter. The loads on my auxiliary panel start to flicker, like the lighting loads. I can see a flicker, a frequency mismatch between, I assume, the battery-based inverter and the micro inverters. I mean, it's just something I noticed, and you know, I don't know if it's dangerous or not, but it happens with fluorescent lights. I see it. It happens with incandescent lights, halogen lights, even LED lights. So something's going on there. Has anyone else seen this? You know what I'm talking about?
I have, yeah. If on the system I've got that's standalone,
Yeah.
I've got all LED lights.
Yeah.
So if I start drawing real heavy on the system, if it's wintertime and all of a sudden the auxiliary heat comes on, you'll see a little flicker. Now, my wife tells me it's not flickering. I say it is. So take that for what it's worth. But
yeah.
Yeah, I
I
wonder.
can see where it does.
I know that the microinverters and the inverters are going to try and sync up with the grid when they're connected properly to get their waveform. So
Yeah.
clearly they're trying to sync up with either your generator or your battery-based inverter. So who knows, maybe they're searching. You said you've got microinverters. I wonder if they're all seeking and searching all simultaneously. You know, it sounds like there may be some issues there.
Well, I've got a mixture of many different models of end-phase inverters. You know, the M215, the M250, the S380, the M190s. So maybe they're just different enough, you know, that some of them are searching and some aren't, or whatever.
Yeah.
Yeah.
I don't
Boy,
know what it is,
you've
but-
got some ancient ones there.
Yeah.
Yeah, I don't know what it is. I always just assume once I had a heavy load on it, since the LEDs have such a small, you know, they're like 10-watt lights that put out equal to what an incandescent 100 does. I just always assumed that it was more sensitive to power fluctuations. So, you know, once it starts drawing heavily on the batteries versus the solar panel or something, and maybe it's not it, but I've got a uniform, there's all this stuff the same. There's no mismatch or no
Is-
variety of inverters or anything.
Is the flicker that you're talking about similar to what happens, I guess, in any home where, like when our well pump kicks on, the lights dim for half a second and then come back on up?
No,
No,
it's a
this is like a,
constant.
yeah, this is
Yours
a,
is a flicker.
yeah. If you better hope you don't have a tendency toward epilepsy.
Yeah, okay.
And
All
I'd
right.
say it seems like the flicker is at about a 5 hertz rate or something, maybe something like that, maybe 10 hertz.
Mm-hmm. Okay,
Yeah, I mean, it's nothing that, it doesn't affect, you can still see, it's not like a strobe, but to me, it's noticeable. Like I said to my wife, she says, there's nothing going on. You're crazy.
yeah, I'd be curious. I'd be, and with lighting like that, it's not an issue, but if you had a kidney dialysis machine and it starts flickering around, maybe the more sensitive the electronic, the more problematic it could be.
That's possible, but I've got, a couple computers and stuff set up around here. I've never had it's never been any effect on that, the printers or it's not like my screen on the computer starts flickering or anything. It
Yeah.
seems to be just the lights.
Yeah. Oh, that's interesting. That's something I've not seen in any of the literature or heard before on that with, and yours is a standard, AC coupled, or is this on your standalone when the generator's going?
This is the standalone, and it's not even really the generator. It's when there's a really heavy draw on the power.
Do you see this
Um,
with your AC coupled system as well?
No,
No?
nothing.
Okay, so I wonder if it is having to do with the inverter being the source of the waveform and not being able to sync up with the grid.
Well,
Okay.
I don't know if it would be because at least at the house where I don't have the problem, I'm still coming through the inverter.
Yeah,
I don't know if, it's it's so-called a sine wave inverter. Maybe under heavier loads, that quote sine wave degrades a bit and you get more harmonics. I think I once looked at it with my scope and it looked like 32 steps, of a modified sine wave, something like that. It
yeah,
wasn't
but I'm
absolutely,
assuming yours is a pure sine wave, but you're saying it may be behaving like a modified sine wave?
yeah.
Okay, yeah, I don't know how pure is in these cases,
Right.
They say it, but it's probably not, it's probably digital in some form and not a pure analog generator. So it's probably very close to pure sine wave, but you look close enough, I'll bet they're, maybe it's modified in some way. Because I guess unless you get a rotating generator, you're not going to get a pure sine wave.
No.
I was
Okay.
just curious. Do you have your monitors on any kind of surge or power filter?
No, I don't use any kind of power filters yet.
Dawn, I was talking.
That's what I figured. I have some of them, yes. At this point, probably they all are. No, I've got at least one or two that's still not on a UPC. But even the ones that are not on a UPC have no problem. But I agree with you. I thought about that too, because if you're running it through a little battery backup thing, it's gonna it'll clean up the power the same way. It would avoid that same issue. You're right.
Okay. Well, let's get back to the MacGyvering world for a second, because like one of my goals was to try and outfit a golf cart with using the batteries from the golf cart, put a little battery-based inverter on it, and see if I couldn't physically disconnect from the grid, but somehow when I'm hooked into my system, still have access to my solar array, to the power that's being generated from the solar array. And I wanted to do a little sanity check with this, because the more I'm thinking about it, the less likely that seems like it's a good idea. Because first off, am I going to overwhelm this little golf cart's battery bank with my 8 kW solar array? So am I going to fry it out as soon as the sun comes out from behind a cloud? So is that an issue? Seems like it could be. Secondly, will any kind of battery or any kind of battery-based inverter that I buy that will produce a waveform that will convince my microinverters that the grid is still operational, will that be so expensive that I may as well go with a pre-engineered N-phase model? You know, because if I'm going to spend $6,000 for an inverter charger, why bother? Why not just go with the manufactured solution? So any ideas there?
The inverter doesn't need to be expensive. My Connect was only $1,500, but I had to do some MacGyvering as far, you know, you can order these optional panels for it that do, you put in circuit breakers and it's got a DIN rail attachment and all that, so that it knows what to do when the power goes out. Well, no, it'll still do. It's got, just like Don's, it's got a internal transfer switch to the inverter. So it comes with that, but you sort of have to rig in other wiring, which takes quite a bit of time. But anyway, it wasn't expensive, $1,500. And that's for 3 kilowatt, 24 volt or 48 volt Schneider Connext, CONEXT inverter line.
Okay, yeah, I'm familiar with those guys because Schneider bought Connext a while ago.
Yeah.
Jay,
So
did you ever try Harbor Freight?
yeah, Harbor Freight works great, you know, for about a minute. So, well, that gets to the other solution, which I've currently used, is just making yourself a little solar generator. And these little solar generators can be pretty big. And then just simply physically plug in to the unit. So rather than going through your household wiring, what I did was took a couple of golf cart batteries, put an inverter in it, just basically built a standalone system in a box. And then if we have a power outage and I want to run my refrigerator or whatever, you just run an extension cord to that solar generator and you just plug in individual appliances. And now you're not having to worry about messing with your home or having critical load panels or anything like that. But that does not take into account my vast solar array that's going to sit there like a you know, an anchor on a boat when the grid is down for 3 weeks because Hurricane Don Meyer struck southeastern Ohio and we don't have power for 2 months.
Right. And we both know where the Appalachians list, you know, how high they are on the repair list.
I know, I know. We may find ourselves as bad as Puerto Rico, where everybody's just sort of going, yeah, they'll take care of it sometime, you know. So,
That's why I'm off the grid. I don't have to pay them not to come fix it.
yeah.
Well, Jay, you can always protect your batteries with a voltage controlled relay. I bought one just to play with, and I set it for 14.2 volts or something. And sure enough, when the batteries got to that level, it disconnected, and the contacts on the relay were 30 amp, I think.
Mm-hmm.
You know, enough probably to handle what you want.
Okay, so you're saying I could hook my array into my battery bank, even though that there's a mismatch in the nominal voltage of those panels?
Wait, not a mismatch between what and what now?
Well, the panels that I've got on there are designed, let's say they're nominal 20 volt panels.
All right, grid tied.
Yeah, the grid
panel.
tied ones. And any
Yeah.
kind of system I would do for a solar generator would be 12, 24, 3648.
Right, right.
So I'd
I
have
think
to
you,
figure
I
some.
think you could
wisdom.
do that. You could hook a large panel like that into the battery bank as long as you didn't let the battery bank get overcharged.
Yep, but I'd probably end up with some sort of row of toggle switches hooked up to each microinverter in my basement, right?
MacGyver.
I know. That would, and since our array is out where all the goats are, I could just see them out there flipping toggle switches with their tongues, that would be great. So, yeah, it sounds like I'm still gonna come back to, probably when I win the lottery, putting the Enphase system in and dealing with it that way. Although I like the idea of solar generators, they're awfully nice as kind of a fun little, emergency, but no more than just something to play with. I don't know, anybody, Eric, you had raised this before as a question. Have we addressed anything close to what you were looking for?
Yeah. I did have a question though. I mean, as a cost strategy, when would you choose to have like two systems, like the off-grid and grid tied?
Yeah, well, of course, that is the whole concept between AC coupled and DC coupled, is to essentially have two systems integrated as one system. If you're designing it,
like Don's kind of. Like,
yeah,
why,
well,
why
Don's
did he
independently
choose his
wealthy, so
approach?
money
Oh,
is no
okay.
object. So.
Well, no, there's a reason, if we get a bad CME, coronal mass ejection, it could fry anything on the roof, including microinverters and an outdoor grid tie inverter, So that's why a backup off-grid small system is good to have around, maybe hidden in the garage or whatever, not hooked up most of the time. Yeah.
Well, you raise an interesting point, Eugene, because I don't think we've really talked about what is it, EMP, electromagnetic pulse issues,
Right.
coronal mass ejections. A lot of that stuff gets into the whole prepper thing, but I'm not so much worried about nuclear war, which is one source of that, because we'll have other issues to deal with. But there is a realistic possibility of large scale solar activity that can cause damage to your system. And that's not something that's outside the realm of, now we're all burying food in our backyard waiting for the zombie apocalypse. We're just saying, all right, there are these things that happen, and they happen relatively infrequently, but they do happen, which is the reason you carry a spare tire in your car and things like that, is because things happen. How do you protect yourself from that? Well, you can get a system like the Solarc, which is supposedly hardened to EMP. To what scale, I'm not sure, but they do advertise it as such. A lot of people I know, some of the serious preppers, will wrap their laptop in tin foil and stick it in a trash can every night, because they're going to, and I always tell them, well, who are you going to be talking to, on your laptop if everybody else is fried out, but you've got the internet, I'm sure. So
They're going to be designing you a new system for you, Jay.
yeah. So yeah, there's things like that are subjected to the electromagnetic pulse. The electronics and the microinverters are a good example. I don't know
Jay,
how you would protect microinverters from.
Jay, I think the coronal mass stuff, that's just the stuff that comes through the wires. Unless your laptop's plugged into the wall, it shouldn't be affected from that. If you had your other one, if you're worried about your Russians, that's when the EMP comes in, that would get the little electronics. The coronal mass ejections were supposedly, they're building up power in the wires, and then it goes through the house and goes through the grid wires and fries your stuff.
Well, I think it goes through it follows any conductive surface.
It does. But the
Yeah.
only ones that are big, because of the wavelength, the only ones from a coronal mass ejection that are big enough to hurt electronics are the ones that are plugged into the wall. The EMP are the ones that have a much different range, is what I understood.
Okay, I'm not 100% confident of that.
Mhm.
Only because then you wouldn't really need a Faraday cage or anything like that. I don't
You
know.
wouldn't for a coronal mass ejection, you would for an EMP.
Yeah,
If the Russians come after you, they've got it. What I understood, they had bombs big enough now from TV that, you know, they're going to put a wave over England and destroy half the US. But
Yeah, it was
that's,
interesting when I was reading about it. A lot of these studies were done in the 1960s during the Cold War. And they did say that modern electronics are about 1 million times more sensitive to these EMP pulses than the 1960s
yes.
things they were testing. So the problem is getting worse rather than better. I can take your word for it because I know you were researching it for your system as far as, but I think there have been some pretty severe, the 18 whatever event.
There have, and the one up in Canada back in the early 80s or the 90s or whatever.
Quebec.
But what happened there is they're taking out the transformers. It's the long wires that are gathering the energy, and then they're zapping the transformers or coming into the house. It has to, and I'm not an expert. I just know they said it has to do with the wavelength, and the different wavelengths affect different. You're right. The EMPs from the Russians, the little electronics, those are the ones that'll supposedly get. And then you have the Army saying, well, we've done our tests and, half the cars started again and half of them didn't. And so you never know for sure who's trying to sell you something.
Yeah.
Well, what I understand is that the EMP from a nuclear device is only really a danger when it's detonated above the atmosphere. Is that true? Yeah.
But when it's high up in the atmosphere and it does something with, gets all the electrons running and
it gets a cascade effect, knocking electrons out down through the atmosphere. Yeah.
Yep.
So I don't know. It seems like if Russia wants
we have
to
a lot
do
of other problems.
way, we would have more time to react because we'd see a rocket go up, and rather than from a submarine, they couldn't do it that way up into orbit. I don't know.
I probably wouldn't notice. I try to avoid the news anyway, so it would all be a surprise to me. So yeah, I suspect this is one of those things we can sort of put into, this is interesting to think about, but probably not a lot of practical application to our life, let's hope. But I think it's, to me, the fun part of it is to say, okay, there are these natural phenomenons that can have an effect on the electronics as they get more expensive or more sensitive and more expensive. So are there realistic practical ways we can help protect or mitigate against some of these adverse impacts? If these things are really 1 million times more sensitive than they used to be, then all we need is a much lower level event to cause us some problems. And can we deal with that just simply by, maybe there's a device you plug into the electric line that is a filter or a barrier or something, or a fuse or something.
They do sell stuff for the ones for the coronal mass ejections. It's a little, I might have something here.
I keep hearing corona mass injections, right? Which is
Ejection,
very,
yes.
very different, very different.
That would be that'd be a very different thing. I'm sorry, ejections if I said it wrong. But these little things, little ferrites, you put them around the cord. Supposedly, when the big charge comes in from the coronal mass ejections from the line, this will. I don't. To be honest, I can't figure out how these ferrites work with the automatic switch, turn off switches either. But putting them around the cord supposedly breaks up the electrical impulse coming in. Tony, maybe you're nodding your head, Tony. Maybe you know more about it than I do, probably. I'm sure
there's a lot you can do to mitigate that with the enclosure, right? So there's a lot of work.
Yeah.
It's not super difficult to either have an enclosure made or buy. I mean, I haven't tried the buy thing. I've just done the make thing. Because what we're doing with some DoD applications, we've looked into that, and it's not, I think, as catastrophic as people think. There's an easy way to help mitigate against some of that. But to Jay's point, I mean, you're talking about, you know, fractions of a fraction of a percent of probability. So the question is, do you want to, you know, spend the extra money for EMP hardening on an enclosure? Cool. But the guts, even though the guts are more sensitive, and a lot of that has to do with, you know, solid state semiconductors and some of the stuff in power electronics in the 21st century, like we're working on. They can still be sensitive. You just put it in a box that can help mitigate some of those events.
Well, I've always wanted to see the Northern Lights, but not in my living room. So, you know, let's try and keep that. Okay, I think we're right to the hour. So I don't know. This was interesting. Let's. So if anybody has any ideas or issues that they want to address in future next week or beyond, let me know. And see you all next week. Thanks for all your help on this. Bye-bye.
Bye.